student, now I solve a question of Newton-Raphson method. Yes, the question is this one. Show that the modified Newton-Raphson method xn plus 1 is equal to xn minus 2 times f of xn divided by f dash xn gives a quadratic convergence when the equation fx is equal to 0 has a pair of double roots in the neighborhood of x is equal to x. Yes, this is the question. So I want to solve this question. So the solution of this question we have defined as suppose x is equal to a is a double root near x is equal to xn. Yes, then f of a is equal to 0 and f dash a is equal to 0, as we suppose that the double real root of this one. Yes, and also we have from the real results or substituting the xn is equal to alpha plus epsilon n, we get epsilon n plus 1 is equal to epsilon n minus 2 times f of alpha plus epsilon n. Yes, as the earlier results I have proved that convergence of the secant method, other type you suppose that xn is equal to alpha plus xn. Yes, or f dash alpha plus epsilon n. Yes, here you suppose that you can say that x is equal to alpha plus epsilon n, as the earlier we have supposed and then we have proved it. Okay, now where epsilon n where epsilon n plus 1 have their usual meaning. Okay, it is not necessary that you have to define epsilon n. Okay, now expanding this and this term by the Taylor series and taking as f of a is equal to 0 and f dash a is equal to 0. You can solve this by you applying this method and now you can obtain the result. Okay, so this one, substituting this one is equal to epsilon n plus 1 is equal to this one epsilon n minus, and here is 2 times and here is also you expand this one f of alpha plus epsilon n f dash alpha plus epsilon n square by factorial 2 f double dash alpha and also this plus so on, or third derivative. Now and similarly here is you can say that f, you start from the here f dash alpha, so f dash alpha plus epsilon n f double dash alpha plus epsilon n square by factorial 2 if triple dash alpha and so on. Yes, clear? Now as you have, it is given for the as x is equal to a is the double root near the point x power x1, so f of a is equal to 0, f dash a is 0, so here is f of at this point of alpha, or you see that not you here we suppose that a, or you here you alpha, here you also can you say here let us this be also alpha and here is also alpha. Yes, here is also alpha, we have to the roots. Yes, here is also alpha because here we are choosing the root is alpha. Okay, so f of alpha is 0, f dash alpha is 0, so this term 0, this term 0. Yes, the starting from here, and this is again f dash alpha is 0. Yes, so you get epsilon n plus 1 is equal to, yes, epsilon n minus, yes, and in numerator you get 2 times, yes, here is epsilon n square by factorial 2 f double dash alpha, yes, plus now so on, yes, and also in numerator you see here start from the here. Okay, so epsilon n f double dash alpha plus epsilon n square divided by factorial 2 if f triple dash alpha plus now so on. Yes, clear? Now if we solving this, then you again get epsilon n, yes, minus 2 times of, yes, 2 multiplied by 2, that is this can be written as 2, yes, and epsilon if you also write down the next term, that is the step third, then here you can also see that this one can be written as epsilon n, that is epsilon n square. Yes, here you can also, if you define, because here is the third term, so also you define the here is the next term is again epsilon n, yes, epsilon n cube, yes, and divided by factorial 3, and if triple dash alpha plus now so on. Yes, clear? Yes. Now 2 times of epsilon n square, yes, and this by 1 by factorial 2. Okay, and here is become f double dash, yes, alpha, yes, plus here is again as factorial 3, that is 3 into 2. Yes, if you have this can be written as, if your 2 is here is, then this can be written as 1 by 3. Yes, and if you also you have taken here the epsilon n square, so here become epsilon n. Yes, okay, triple dash alpha plus now so on. Yes, clear? Yes, if you also take the third term is also here is. Okay, so this is cancel out. Okay, and here denominator is also, this can be written as epsilon n. Yes, epsilon n is here, epsilon n, and here is f double dash alpha plus epsilon n, yes, by factorial 2 f triple dash alpha. Yes, clear? Okay, now here is epsilon 1, here is epsilon n square, so this is also cancelled out. Okay, so this is also, so here you get not, because you have take the approximate time, so you approximately you can say that. Yes, that is approximately you can say, because you neglect the some other terms. Okay, epsilon n, yes, minus here is also epsilon n is here, so epsilon n, yes, here is f double dash alpha plus 1 by 3 epsilon n f triple dash alpha plus up to so on. Yes, but you approximate value, so you close this bracket here. Yes, approximate we have to. Okay, now here you can also, because you take the approximate sign, so here is also f double dash alpha plus epsilon n by factorial 2 f triple dash alpha. We close the bracket. Okay, now this is equal to, here you see that we dividing the whole expression by f double dash alpha. Yes, and here is a, or you can say that the epsilon n multiplied by this thing, and taking the LCM of this is the epsilon n, this term is cancelled out. Epsilon n square of this term, here is also epsilon n square. Then 1 by 2 minus 1 by 3, which is become 1 by 6. So this is approximately, you can say 1 by 6 epsilon n square f triple dash alpha, yes, divided by triple dash alpha divided by f double dash alpha plus epsilon n f triple dash alpha divided by. Is clear? Okay. Yes. Here you see that you have given that because that this is in the power of, here is that epsilon double dash, here is also, so this can be also approximately, you can say that 1 by 6, yes, epsilon n square, because you numerator divide denominator divide f double dash alpha, then this is equal to this approximately f triple dash alpha divided by f double dash alpha. Yes, now neglecting the alter term, which shows that, yes, which shows that, yes, shows that epsilon, yes, epsilon n plus 1 is proportional to, yes, epsilon n square, and the convergence is quadratic. Yes, and the convergence is quadratic. Yes. 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 In this way, you have to solve this question. Yes, students. Thank you.